Ever find yourself, wishing you had a sidekick? Someone or something that could just crunch through massive amounts of data, make those intuitive leaps, maybe even write that report that's been sitting on your desk.
Like having a super brain just a call away.
Exactly. Well, it might not be as far-fetched as it sounds. We're diving into the world of neuromorphic computing today.
Which is basically striving to build computers that function more like the human brain. We're talking mimicking its structure, how insanely efficient it is, even the way it learns.
It's not just about making computers faster, though, is it? This feels different.
It's a whole different ballgame. We've been designing computers based on, well, frankly, outdated ideas about the brain, kind of like trying to build a spaceship using the Wright brothers' notes.
And neuromorphic computing says, why not go straight to the source?
Exactly. Let's replicate the brain's intricate network, those billions of neurons and synapses.
Okay, so time for a quick neurology refresher.
Sure.
What exactly are neurons and synapses? For those of us who haven't cracked open a biology textbook lately.
Think of neurons like tiny messengers sending electrical and chemical signals throughout your brain. And each neuron can have thousands of connections to other neurons in those connections. Those are your synapses. That's how information flows, how it's processed. It's a massive interconnected web.
So not like our current computers, which process information one step at a time.
Right. The brain's all about parallel processing, doing a million things at once.
Just like we are right now, listening to this, and let's face it, probably thinking about a million other things.
Exactly. That's the beauty of it. This parallel processing is what makes the brain so amazingly efficient and adaptable. Think about it. Your brain can outperform even the most powerful supercomputers on certain tasks, all while using a fraction of the energy.
That's incredible when you think about it.
Yeah.
We're talking massive energy savings, which, let's be honest, we desperately need.
Yeah.
But where else does this all lead? What are the really big things on the horizon with neuromorphic computing?
Imagine running simulations, ones that would bring today's power grids to their knees, on something like your phone.
Wow.
That's the kind of energy revolution we're talking about, especially with how much our reliance on data keeps growing. And it's not just about saving power. Remember that parallel processing we talked about? That means speed. Handling stuff like image recognition, natural language processing, way faster than our traditional computers ever could.
Okay, so we've got energy efficiency, speed. What else? What's out there that really captures the imagination?
Think about the things our brains do without even breaking a sweat, things that still leave even the most advanced AI completely stumped.
Like what? Give me an example.
Understanding nuanced language, really getting all the subtle meaning, or recognizing patterns in complex data, even just making those intuitive leaps.
So hold on. We're not just talking about slightly smarter phones here, are we? We're talking about machines that could potentially reason like us. I mean, where does that even lead?
It leads to some really exciting possibilities. Think about medical diagnoses.
Okay, yeah.
Imagine a system that could analyze medical images, but with that human-like intuition, picking up on those tiny anomalies that conventional methods might miss completely. It could revolutionize healthcare.
That's incredible. Okay, let's back up a bit. How do they even start building these brain-like systems? What's the magic happening under the hood?
It all starts with artificial neural networks, or ANNs as they're called. They're basically software constructs trying to replicate that web of neurons and synapses that we find in the brain.
So software that's mimicking the brain's hardware.
Exactly. Now, there are different kinds of ANNs. You've probably heard of deep learning. That uses one type, but neuromorphic computing often uses something called spiking neural networks, SNNs for short. These are designed to be even more brain-like. They use timed pulses or spikes to communicate instead of processing information as continuous values like in deep learning.
So it's mimicking the actual way that neurons transmit information.
Precisely.
Wow. It sounds incredibly complex.
It is, and it's not just a software challenge either. We need specialized hardware, neuromorphic chips, which are built from the ground up specifically to support these computational models. We can't just run these brain-inspired networks on traditional computer chips. It just won't work.
A complete hardware revolution.
Yeah.
What are some of the biggest hurdles researchers are facing as they try to develop this technology?
Well, for one, building larger, more complex neuromorphic chips. We're talking billions, even trillions of artificial neurons and synapses. And then there's the challenge of figuring out how to program these things. I mean, we need entirely new programming models and algorithms that can work with these unique asynchronous systems, traditional programming languages. Those techniques just aren't going to cut it.
It's like writing a symphony. but for an orchestra of instruments that have never even existed before.
Now, that is a great analogy. And then the final challenge, maybe the most daunting of all, is what we call biological fidelity.
Okay, I'm not familiar with that one.
Well, we've made huge strides in replicating certain aspects of the brain, that's true, but creating artificial networks that truly capture the complexity, the adaptability, even the mystery of the human brain. That's a whole other frontier. We're just starting to dip our toes in the water.
So we've talked about the challenges, but while we're waiting for these, artificial brains to reach their full potential, what's coming up soon, is this stuff already out there in the world?
Oh, absolutely. We're seeing it pop up in some really fascinating applications. Robotics is a big one.
Okay, how so?
Neuromorphic sensors, they're giving robots a much more, human-like awareness of what's around them.
Interesting.
They can process sensory data in real time, which means they can react and adapt to changing environments so much better.
So instead of being stuck in a carefully controlled factory floor, these robots could navigate, say, a crowded room full of unpredictable humans, things like that.
Exactly. And we're talking just the beginning. This is early stuff. We're also seeing neuromorphic vision systems being developed for self-driving cars.
Now that's something I'm interested in. How does that work?
Imagine a car that doesn't just see objects, but it actually understands the whole scene, almost like human perception, anticipating things that could be dangerous.
I think I'd feel a lot more comfortable handing over the wheel if I knew the car was actually, understanding what was happening around it, not just reacting to objects.
Yeah.
What about now, though? How is this technology showing up in our lives right now?
You've got your phone with you, right?
Always?
Neuromorphic chips, they're being used in something called edge computing, basically bringing that brain-inspired power to smaller and smaller devices.
Hold on. So you're saying my phone could soon have, a tiny little brain of its own?
In a sense, yeah. Faster processing, way better battery life, running more complex AI apps, all on your device. You wouldn't need to rely on the cloud for all that processing power.
That's wild. So we've gone from the inner workings of the human brain to robots navigating rooms, and now our smartphones are getting a cognitive upgrade, all thanks to neuromorphic computing. It's pretty clear this technology has the potential to completely change, everything.
And the most exciting thing, we're just getting started. As these systems keep getting more and more sophisticated, it makes you wonder, what does thinking even mean anymore,
It's true.
What happens when machines can learn like we do, adapt to new situations, make those intuitive leaps?
It's almost a bit much to get your head around. I mean, if we're able to build something that complex, something that sophisticated, what does that say about us? About consciousness? It kind of goes beyond just technology, doesn't it?
Yeah.
Gets into some pretty big philosophical questions. Maybe trying to build a brain on a chip will teach us just as much about ourselves as it does about, the future of technology.
I think so too. It's a really exciting time to be working in this field.
Well, on that note, we'll leave you all to ponder the incredible possibilities and maybe grapple with a few of those big questions. It's been an amazing deep dive into the world of neuromorphic computing, and we can't wait to see what incredible breakthroughs are coming next. Thanks for joining us.